Welcome to lesson 9 of this Arduino C++ course, and today we're going to be looking at arrays and the for loop. Now, for many programmers, arrays are a bit of a nightmare. They find it very difficult to get their head around them, so we're going to try and take this easy, and we're going to start with a very simple example. So as you can see from the breadboard, we are using the same circuit as in the last couple of lessons, and all we're going to be working with today are the LEDs up here. And as you can see, they are cycling through, one turning on after the other in a sequence, and that's literally what we're going to build. And we're going to build it in two different ways, one with the array and one without. Now, as always, if you go to the Digital Town website, you will find the reference to go with today's lesson. Just scroll down, as always, to the bottom to lesson 9 we're on today, and you will see not only the circuit diagram that you can sort of click on to get a bigger version, but also you can download the code. Now, going back to the circuit diagram again, we're only using the LEDs today, so if you haven't got these other components, don't worry about it. Looking at the first sketch, as always, I have listed all the pins that are connected. Now, obviously, we're not using all of these items today. All I am going to be using are the LEDs, which are on pins 5 to 12. I've therefore set up all of those as integers, and I've given a name to each LED as always. So I've got sort of a right blue LED, a right red LED, working down to the left green LED. Just that's the way I've had to describe them. I've got a variable Q. This is just going to be used as a counter. When I'm just using a variable as a counter, I will tend to use one single character rather than typing out a longer name. Now, if you find it easier, type out a longer name, make it something more descriptive. I tend to use something very simple because it's faster to type. And those of us who've been programmers for a long time, we tend to be a little bit lazy. Why do I pick Q? Top left on the keyboard on my type of keyboard. As always, there will be no delay in this code. This is non-blocking code, therefore we will be using millis as always to control our timing. Moving down to the setup, nothing new really. As always, serial begin, and I've got the output of the lesson just so that if you like, I plug the Arduino back in, I know exactly which bit of code is on the Arduino. And then I have set all of those LEDs as outputs. We've done all of that before in previous lessons, so now let's go down to the main loop. So the main loop is fairly simple. Once again, we've got the timer code that we've used in most of the previous lessons. We take the board time in milliseconds. We then see if the difference between the timer millis and the current time is greater or equal to the timer delay. Now, if I put my mouse over there, the timer delay is currently set to 1000, which is 1 second. So every second, this code will run, and then as it runs, we're resetting the timer ready for the next rotation. Within that timer, I've then got a very simple switch statement. And the switch statement is switching the value of Q. So that is the value that I declared up here, and it's just a counter. Now, what happens with Q after the switch statement? So we've got this great big long switch statement that goes on and on and on and on. And after we get to the end of that switch statement, we then have this little statement here, which increments the value of Q by 1. So if Q was 0, if you go Q plus plus, Q becomes 1. If it's 1, Q plus plus, Q becomes 2. Now, obviously, I only have 7 cases. So if Q gets to a value that is greater than 7, it immediately resets the value of Q back to 0. So if you like, the whole process starts again. And then working through the switch statement, if the value is 0, which is case 0, I'm turning on the right blue LED, I'm sending that high, all the other LEDs are being set low. Case 1, I'm going to set a different LED high, again, all the others are low, and that's all I've done. Each time I have changed the LED that is set high, while all the other LEDs remain low, and that means that every 1 second I will progress through all the LEDs one at a time, so it looks like that one LED just progresses through, turning on while the others are all off. So going back to the webcam, that is exactly what we are seeing. If we work our way through, we get 0 here, it turns on the LED while it's turned off all the others. When the case is 1, the red LED comes on while all the other LEDs are turned off, and that's how it works through the whole cycle. Now, coming back to the code, obviously the project is working, there's no problem with that, but let's be honest, writing out all of this is a bit of a drag. It's quite time consuming and it becomes very easy to make errors. And one of the great things about using arrays is that very often you are able to reduce the amount of code that you need to write. Now, this sketch, including all the comments, is 148 lines long. So now let's look at the version that we're going to write using an array. Just before we start, the last sketch was 148 lines long. This is 73 lines long, so less than half the length, and this sketch has more comments in it, so I've actually added lines in. So that's going to just give you an example of how much time you can save using arrays. So going back to the top of the sketch, as always, the header is the same, everything's there. In the previous sketch, we created an integer value for every single pin. An array works in a very different way. So we set up an integer, and I'm going to call it LED pins. And you notice I give it the value here of 8. That is because there are 8 values that I need to store. Now, you can put a blank in. So you put nothing in there, but as I'm preloading the values, as I put 8 values in, that will automatically make this array what they would call 8 elements. Each of these items is an element. If I didn't have these values here and I was just creating the array as an empty array, in which case the line would look like this one. So that would mean it has created the array with 8 elements, and each of those elements would start with a value of 0. So that would be how I'd create that array. Now, the important thing with arrays is you cannot change the number of elements in the array once you have started your code. So you can change the value that is stored, but you cannot change this value. So if you start with 8 elements, you are finishing with 8 elements. If you start with 2 elements, you are finishing with 2 elements. So it's quite important to know what the size of the data is that you are putting in. So for this example, I'm just putting in the pin numbers, and then what I've done here is I've just created a block comment just to show you an alternate way that I could have put the values in. If I had created the variable, so if I created int LED pins and then that 8, I could have then filled it with the following. So this would have created the array and everything would have had a value of 0. I could then go LED pins 0 equals 5, 1 equals 6, 2 equals 7. And this is what builds up the array. So there are 8 elements. Think of it as a variable that can store 8 different items in this case. So it's still storing an integer value, but it can store 8 of them. And the great thing about them is we can access them in any order that we want, as long as we know which number in the array to call up. Now, as before, I've got my global variable Q and I've got my timer. Now we're going to come down to the setup and you'll see how I've started to use what is called a for loop. This is the for loop. And as you can see, I've got my variable Q and I'm saying for Q equals 0, Q is smaller than 8, Q plus plus. Now, how this works is it says, okay, we're going to start with a value of 0. And so what I'm doing is I'm going to serial print out the value of Q. I'm then going to serial print out the pin number that is stored in that element of the array. So if you like, the Q value is 0, it will print out whatever value I have stored in element 0. Now, I know from my sketch earlier on that the value in element 0 is 5. The for loop is then going to run round. It's going to come back again. Notice it did a Q plus plus. So now Q isn't 0. It's now set to a 1. So it's come back and it's saying, okay, 1 is still smaller than 8. It's going to do another loop. Q is going to get incremented, and this time the value of Q will be 1, and it will now output the pin value that is in element 1, which is 6. At the same time that it is doing our serial print statement, I'm also doing the pin mode for my LED pins. So each loop, it's going to do the pin mode for the value that is stored in that element of the array. So instead of me doing a pin mode on right blue LED, now all I need to do is do the LED pins and the value of Q that is these values stored in the array, and again simplified in this version here. Now, it's very important to understand the for loop, because for loops and arrays, when combined, are very, very powerful tools. So just get used to that idea that this is just working through a number of items. Now, one of the reasons it starts at 0 is that all arrays start with 0. So if you have 8 elements in the array, then it starts at 0 and the highest numbered item will be 7. That's just one of those oddities that you sort of have to get your head around. When you are programming, a lot of the time you will find that values do not start at 1, they start at 0. So coming down here, one of the great bits is the value. The reason I love to use this Q is smaller than 8 is it means if I know the number of items in my array, if I put this value in here, then I'm always going to run through the array correctly. It is very important that you do not put the wrong number in here. If I put 20 in there, this loop will continue to run. The problem is it will overrun the edge of the array. It's one of those things that can happen on the Arduino. Other boards have some protection put in to stop that, but on the Uno it's very easy to start reading other bits, if you like, from the memory that are nothing to do with the array that you are working in. So very simple. The for loop is working through one element at a time, and as the value of Q changes, we can read the different value from the different elements of the LED pins. And for this example, that's just going to be the pin number. So let's just upload that and look at the output. So I've uploaded the code, and as you can see on the serial monitor, we're going to work through the values of Q, and I've listed those values here. So we get Q equals 0, and then we get pin number. That pin number is stored in element 0, and we can see that that value is a 5. For element 1, we can see we've stored a value of 6, and so on, working through to element 7, where we have a value of 12. So whether I'd put those values in like this, or as I've done in this way, the output here will always be the same. So that's, if you like, the first example of using the for loop with an array. Coming down to the main loop, as I said before, this is a much shorter bit of code than the original one. So let's have a look at what we've already understood from previous lessons. All of this here to do with the current millis and the timing, we've done that before, so I'm not going to go into that timing system. I've got one new variable, W, which is a local variable. Why did I pick W? Well, it's next to Q on the keyboard, and I'm lazy. I'm just using it as a counter, so I don't want to use a long name. So let's have a look at what is going on. Just as before, we are incrementing the value of Q, and just as before, when Q gets to a value greater than 7, and it's important because don't forget we've only got 8 elements in the array and we start with 0. So if it gets greater than 7, we're going to reset the value of Q back to 0. Then all I'm doing is, as the loop goes round, each time I'm setting the LED pin high that is stored in LED pins Q. So if this was 0, then this is going to set pin 5 high. In fact, if I put my mouse pointer over, you can see exactly how that's going to work. Element 0 will be 5, element 1 is going to be a 6, 7, 8, 9, and so on. So as Q increases in value, that is going to change the pin that is set high and lights up. Now obviously that's great, I've turned the LED on. Now I've got to turn the other 7 LEDs off, or at least make sure they are off. So for that, we are going to use another for statement, this time without, if you like, using the array. And all I'm going to do is go for W equals 0. W is smaller than 8. So again, I'm going to work through 8 elements. And this time I'm going to use a very different if statement. You'll notice here I've got this sort of exclamation mark equals, and that is listed over here. And it means that the if statement is true if W is not equal to Q. So what this is going to do, it's going to work through all 8 elements of the array, and it's going to set the pin low. So it's going to turn the LED off if it's not equal to the value of Q, because we don't want to turn that LED off because we've just set it high. So this is, if you like, a for loop that is now working through the array in a different way, this time checking that I'm going to turn off all the LEDs that are not the same as the LED that has just been turned on. And as you can see, when the code is uploaded, it works in exactly the same way as the first sketch did. The big difference is, obviously, we have a lot less code to write. Now, for the final modification to the sketch today, I'm just going to change the way that the value of Q is generated. At the moment, it's just incrementing through between 0 and 7. And that's how we get, if you like, that repeating cycle of the pins. What I'm now going to do is use a function called random. Now, if I just bring up the reference, random, if you need to find it in the Arduino reference, it's sort of down towards the bottom under random numbers, and you can just put this little bit of code in, random and a maximum value, and it will pick a number, a random number between 0 and 1 less than the value that you put in here. So if you put an 8 in, then it's going to pick values between 0 and 7. So going back now to my code, rather than going through those pins in a fixed order, I'm now generating random values. I'm just going to bring the camera back in, and we will bring the serial monitor up so you can see what's going on. So you can see it's generating this set of random numbers, and as these numbers come up, you can see that the LEDs are changing color depending on which pin has been picked in the array. So as you can see from that, we're just changing the value, and it just shows how you can very easily access a value at any point in an array. You don't need to go through in a specific order. You don't have to work your way from 0 down to 7 in my case. You can just go, okay, I just want to know what is the value that is stored in element 5, element 3, and I can work immediately with that item. I'm going to finish the lesson there for today. I hope that sort of helped a little bit with the arrays and the for loop. We will be using them in the following lessons. Some of the request items that have come in are for servos and for stepper motor control, and you're going to see how arrays can be used to help with both of those items. So we'll build those into the following projects, and if you have any other components that you want me to put on the project list, please put it in the comments or drop me a message off the Digital Town site. So I hope that's been useful for you, and I'll see you in the next video. Bye for now.